Hey folks, Mr. Dell here. We are looking at describing or given a situation, can you create a graph from a situation and then describe that graph? So this is coming from CPM Math 2, and this is specifically section 7.2.2. Number 7-90. So we've got three situations that we're gonna create graphs for. So I'll walk you through that process. The directions say sketch a graph that represents each situation. Describe the features of the graph completely. So the first one, Raphael walks from his home to the store 1 mile away in 15 minutes. He shops for 30 minutes. Then he waits for a bus outside the store and takes the bus home. Represent the distance from home over time. So the distance, so we're representing, here it tells me what my axes are going to be. Distance from home over time. So my function or my representation of this graph, it's going to be all positive. So I just need to have the first quadrant, right? Because time is never negative. Distance from home is not negative. Distance is going to be positive. So I'm gonna call my x-axis time, and we'll deal with time in hours. Actually, time in minutes. I'll do time in minutes because that's what we're given. And then this one, I will do the distance. So my y-axis here, okay, my y-axis, my x-axis. My y-axis is distance from home. Okay, so we say what's happening at 0 time. At 0 time, he's still at home. Distance from home, there's 0. We'll do this in miles because that's what it gives us is miles, right? So he's 0 miles from home. So that point exists. 0 exists. At 0 time, he's 0 miles. So what does it say? It says he was 1 mile away. In 15 minutes, he walks from his home to the store that is 1 mile away. Okay. So I'm going to put up here, it looks like if I read this, that's as far as he goes. He's only going to get 1 mile away. So that'll be 1, and that'll be a half a mile. And so 15 minutes. So what do we have? 15 minutes. Then he's shopping for 30. Then he heads home in a bus. So we'll make this say 60 minutes, up to 60. So there's 15. There's 30. 45. Should we move that over a little bit? Oops. Let me erase all that. And then there's 60 minutes. So it's 15. So in 15 minutes, he walks from home and he's at the store 1 mile away. So it takes him 15 minutes to walk 1 mile. So if he's walking a consistent pace. So he's getting further and further away from home, and we'll make it a nice even pace. He's just walking from his home to the store. So right now he's a mile away from his home, and it's been 15 minutes. That's where that point comes from. Then it says he shops for 30 minutes. So he's at the store. So he's not going any further away from the store. So for 30 minutes, so from 15 to 45, he's still at the store. Right? So this is him at the store. So I might put some little notes here. So at store, right? This one we might put a little note here. So this is where he's walking. Okay. And then they keep going. Now what happens? And then he waits for a bus outside the store. So he actually waits a little longer, and then he takes the bus home. Well, think about the steepness of the walk, right? The walk was that steep. It took him 15 minutes to walk 1 mile. If he's on a bus, it's going to go a lot faster, right? It's not going to take 15 minutes to go a mile. It might be 5 minutes or less, right? So I'll just say he's outside for a little bit waiting for the bus, and then he heads home, and so it's going to be a lot steeper of a drop because it's only going to take him maybe 5 minutes to get home. So there we go. So now he's at home, back to home. So we'll label that on bus. So on the way home. Okay. All right. So there's my first graph. So let's talk about the second graph. And I did some description there with the features. So what about B? B says Suwata works at a gym 15 hours a week. She makes $9 an hour plus a $10 bonus for each new gym membership she sells. Represent her weekly earnings based on the number of memberships she sells. Well, let's see. Doesn't tell me. So I'm going to do, let me see, I'm going to do a represents her weekly earnings based on the number of gyms that she sells. So I want representing her weekly earnings, and it's based on number of gym memberships. All right. So we would have the x-axis. Let's see what we got here. The x-axis is going to be number of memberships. Let me do that again. Number of memberships. The y-axis here, so that's my x-axis. The y-axis is going to be her weekly earnings. So that's the money. Okay. So it says, so really this $9 per hour. Well, she gets the $9. So yeah, $9 per hour plus a $10 bonus. So if she's working, oh, it tells me right here. Okay, it's 15 hours. Okay, so if she's working 15 hours a week, how much money is that? So let's start there. So we know if she has 0 memberships, right? That's where I'm going to start my graph. If she has 0 memberships and she working for 15 hours, that's going to be 100 and let's see, 45. So 45. So 135. So together, that's $135. So at 0 memberships, let's just make this 100, make that 150, make that 200. So at 0 memberships, let me change my color here. She's going to have $150. Actually, not 150, 145, 135. So let me go below that. Oops. $135. So we'll put it here to represent 135, right? So then if we said at 1 membership, it'd be $10 bonus. So she grows 10. 2 memberships, she would be her same wage, right? Her same weekly wage doesn't change. It's going to be plus 10. So now if she sells 2 memberships, it's plus 20. So 135 plus 20 is 155. And then at 3 memberships, she would grow another $10. So 165. Let me try that again. There we go. Lost it for a second. Okay, so at 2, oops, I lost my points too. She was at 2 at 155. At 3, it would be 165. I lost my page again. Sorry, let me get that back. Keeps cutting out on me. Okay. All right, let's keep going. Here we go. So let me redraw this. I must be pushing something wrong here. All right, so at 2, if you notice, basically every time she sells a membership, she's climbing just $10, right? 4 memberships, $10 more. So it's always the base pay. And notice I'm not going to connect my dots because she can't sell 1.5 memberships or 2.5 memberships. It's a discrete situation where it's just these dots. All right. I think that's good enough. That shows that one. Let's move on to the next one. So last one here. Tom has 500 in savings account, right? And for balances under 1,000, the bank does not pay interest. For balances over 1,000, the bank pays 3% annual interest. On the last day of each month, Tom deposits $150. Represent his account. Okay, here's our graph. Represent account balance over time. So there we have it. So account balance is my Y, and over time is my X. So times X, and I'm going to make time. He deposits 150 each month. I'll make the time in months. And my money is his balance, right? On the side is account balance. Okay, and we'll go, looks like because we got to get up to 1,000, so we'll show this as every 100. Actually, we'll just do 150 each time. So 150, because that's where he makes deposits. Oh, I know, actually, because he's going to start with 500. Actually, sorry, let's do this. I'm going to make this 100 each time. So 100, 200, 300, 400, 500, 600, 7, 8, 9. I'm going to run out of room. Let me try that one more time. Maybe I better go by 200s instead. Let's do that so I have room. 200, 400, 600, 800, 1,000, 1,200. Okay, so there we go. So there's my thing. So let's say he starts, what do I see? Tom has 500. So he actually starts with 500. So we got to go to 500 at 0, right? Because that's when we start. He's at 500. And then at 1 month is at the first month, he deposits 350. So he's depositing 350. So on the first month, on the last day of the first month, right? So at the first month, now he's got 150 more. So that would be 550, which would be somewhere right here. Okay. And at the second month, it's 550 plus 150 is 700, which would be right about here. And then the third month, another, so we would be 850, which is just above 850, would be right about there. And then at 4 months now is when he hits the 1,000 mark, right? So 850 plus 550 is 1,000. So let's talk what's happening. Is this discrete? Like in between 0 and 1, what is his balance? Well, his balance actually between 0 and 1 stays to be whatever it was during that month, right? So in the first month, it stays. And then what happens, I'm going to put a closed dot here because it changes on the first day of the month. He's at now 150 more. So that stays the same. That stays at 650 through that entire second month up until when the next month starts, right? And then again, it stays. So every one of these, he's staying at that same balance until he gets to 1,000. At 1,000, though, it says that the bank starts to pay 3% annual interest. So instead of it now growing, instead of staying even, it's going to start to grow gradually. And then he'll take another jump at 150 up above that. So it's not going to be as high as a jump, right? And then it'll grow, and then it'll continue to he takes another 150 jump and it'll grow. So it maybe looks something like that. All right, so there's a representation of each of these situations. All right, there you go.